So this is called the elimination method, and it's where we create matching but opposite coefficients. A coefficient is just the number in front of the letter. So we create matching but opposite coefficients, or numbers in front of the letters, for one of the variables. Then add the two equations in order to eliminate that variable. That's why we call it elimination. We're trying to get rid of either the x or the y variable. So you're going to want to get rid of either the x or the y variable. So think of it this way. We're going to create matching but opposite numbers in front of the x or the y, if they're not already matching opposite, and add the equations. Yes, those are three different examples. You can see, here's what I mean. In this first example, see how the positive 2 is in front of the y?
Yeah.
And the negative 2 is in front of the y below it?
Yeah.
When I add those equations together, the y will end up disappearing.
Yeah.
So that's the idea behind elimination. Maybe another way to put this would be create opposite but equal terms. You want to sort it up. But equal terms. Because they need to be opposite signs but the same numbers in front of the x's or y's. And then you can add vertically and they disappear. A lot of students like this better than substitution. Well, we'll see. If the equations are something like this, it's hard to beat this method of elimination here. If I add these two equations together, take x plus 4x, and that gives me 5x. We're going to add the two, okay? And then 2y minus 2y, they cancel out. They get eliminated or equals 0. And then what's the right-hand side equal? Well, 10 plus 5 is 15. And so I have this equation, 5x equals 15, with no y in it. Y has been
gone. Eliminated.
That's why it's called that. Eliminated. Why? Well, because, Travis, when I added these two equal but opposite coefficients, they canceled out. Okay, what's a coefficient again? Something what?
With a negative.
No?
No, something.
What is it?
Something that has the same values.
Okay, it doesn't have to have the same value. It's just a coefficient is just a number in front of the letter. Okay, what about this equation? What happens when I put a line underneath it and add it? Do I get to eliminate one of the variables? Max? Can you tell me which variable gets eliminated when I add these two equations? Can you tell?
Variable?
Yeah, which variable, which letter, x or y, gets eliminated when I add those two? Yes. This time, x gets eliminated. That equals 0. And y plus negative 2y is negative 1y. And 4 plus negative 14 is negative 10. And so I end up with a very easy equation to solve. Guys. Okay, so in both of the first two examples, I added the equations, and automatically one of the letters was eliminated. In the first one, it was y. The second one, it was x. And I'm going to show you what to do from here. I think you probably already know what to do. How would I solve for x here? Divide, yeah, and I get x equals 3. So, do you remember, okay, some of you actually, I told you guys this today, on the substitution method, once you get x equals 3, you're not done, right? You still have to plug 3 into one of the equations for x and find y. Same deal here. But it's hard to beat elimination when you have two equations in standard form that you can just add up. Now, What would happen if I added these two equations on the third example? Would a variable be eliminated? And if so, which one? 4 looks like it could be eliminated, but if I add 4y and 4y, I'm going to get 8y, right?
Oh, yeah.
It's not, but any ideas out there on what I could change throughout this equation so that when I add them, the 4y's are canceled? What could I multiply each of these terms by so that when I add it here, the 4y's are canceled? Yeah.
3.
3. Okay, if I put 3, I'd get 9x and 12y and negative 9. I need more than just multiply them. I need them to be opposite signs.
-3.
You're on the right track now with the negative. I wish I had a negative 4y here. If I want to have a negative 4y here, I need to multiply each and every term by -1. So if I make that a negative, what else has to be made negative? Everything, and that becomes a positive 3. So what I'm doing is multiplying through by a -1 and switching all the signs, yes. And that is one technique before using elimination, is to change all the signs by multiplying through by -1. Here's what it looks like. We usually do this, put parentheses around it, and put a -1 out in front, and that tells me to multiply each and every term by -1. So it looks like this: -3x minus 4y equals positive 3. And then I would just take this equation right here, let me do that, the blue equation, and write it right underneath. 6x plus 4y equals 6. Okay, I'll move. I always move after I write. So I'm multiplying the second equation through by -1, and the first equation, I just copy it down. Now I can add them and eliminate the y. So a little bit of wishful thinking. I wish I had a negative 4y there. Well, I can make this a negative 4y by multiplying through by -1. What algebra rule, Travis? What algebra rule in equation solving allows me to multiply through by -1 and not change the equation? Can I just multiply this by -1 and be good to go?
No.
If I multiply this by -1, what else do I have to do to the equation to keep it in balance?
You have to multiply this.
Multiply the other side by -1. So if I do, whatever I do to one side, yes. So when I add these, -3x and 6x is 3x. The 4y's cancel, right, Marcos? Marcos. Okay, the 4y's, do you see why they cancel?
Yeah.
And then equals 9, and then, you could probably do this in your head, right?
No.
X equals what?
3.
3, yes, good. All right, so we haven't done any of these first 3. We didn't do the whole problem. We only set it up.
Yeah.
Okay? Let's go ahead and do one problem from start to finish. So problem 1. It says, what is the solution of the system? So if I were to graph each of these, what would it look like on the graphing grid? No, wouldn't it be weird? It'd be something that's studied all first semester.
A line.
Yes. It'd be 2 lines that are intersecting, yes. Yeah. Not necessarily perpendicular, but intersecting somewhere. So I'm finding where they intersect. So can I just add these 2 equations together and eliminate one of the variables? Yes, yeah, I can. Which variable gets eliminated? The y gets eliminated, that's right. So 2x plus 6x is 8x. The y is eliminated. 17 plus -9 is 8, right? Now let's finish the equation.
You divide x equals 1.
X equals 1 because when I divide each side by 8, I get x equals 1.
You get 1.
Let's circle that just to keep track of it. So now, if x equals 1, am I done?
No, you have to plug it in.
Yes.
So you can make your own.
Yes. find the rest of the solution. So plug 1 into one of these two equations. It's your choice. I'm going to plug it into the top one here. Whoops. So I'm going to take this top one. Let me just write it down. And then I'm going to put 1 in right here. So it's 2 times 1 plus 5y equals 17. The previous 3 ones, I was just leaving it. I was just showing you how we eliminate the variable. This one we're actually going to solve all the way to the end, okay? What's that? You probably could. So this is 2 times 1 is 2. Okay, guys, I'm going to wait until it's quiet. I want to make sure everybody sees this step. I don't want everybody just to stop at the x equals 1. It's pretty easy to get the x equals 1, right? In this problem, it's kind of. But let's go ahead and finish this. So subtract 2 from each side. 5y equals 15. Divide by 5. So subtract 2 over. You get 17 minus 2 is 15. Divide by 5. So I have y equals 3. And then we write our solution as an ordered pair, 1, 3. That's it.
I did it before you did.
Good. I know, I heard several of you had the 3 before I did, so that's good. See, do you see why we learned substitution first?
Yeah.
What did we do to get the 3?
We solved y and x.
What did we do to get the y? What process?
Plug in the x.
Yeah, plug in, which means substitution.
Yeah.
That's why we learned substitution first. Is anybody still writing? Give it another 50 seconds. Yes. There it is.
Yay, no, that's horrible. I don't want to be. He's lying, he left his class. I want to go home. Henry's lying. Henry's not lying.
All right. A couple more finishing up writing, and we'll go to the next. You can flip to the back side here. We have a word problem. Real life sort of problem. We're going to set up the problem and use elimination to solve it.
Like 40 water dogs and things.
No, not on this one.
Someone bought 41. Okay, just because.
All right, it says the theater club sells a total of 101 tickets to the play. They sell student tickets and they sell adult tickets for different prices. Okay, that's pretty typical. Guys, I'm going to wait till it's quiet. We'll be back after lunch.
I don't.
I need it quiet.
Are you telling Dad?
I'm still waiting, guys. I need quiet, please. Okay. So the student tickets and adult tickets together, if I let S equal student tickets and A adult tickets, they add up to 101. So we call that equation the total equation, the one that says how many total tickets we sold. Right. The other equation has to have the price in it. So it's $1 for student tickets. So do $1 times S plus $2.50 for adult tickets. What a deal. And the total ticket sales are $164. So those are my two equations.
Step outside, please.
So if I were to use elimination, I can't directly add them. If I added them, if I just put a line underneath it and added them, I would get 2 S's and 3.5 A's. That doesn't eliminate either the S's or the A's, right?
Nope.
So we got to use that trick where we multiply through by -1. Here's what I would do. Take this first equation, and I'll do it in a different color here. I'm going to multiply through by -1, giving me a new equation of -1s minus 1a equals -101. So I'm multiplying through by -1 each and every term before I go and try to add the equations together. So if I draw a line underneath these, put a plus sign out here, the variable that gets eliminated is the s, right? 1s minus 1s is 0 s's. 250 minus $1 is just 150 a, and 164 minus 103 is 63. Oh, 101, yeah, minus 101 is 63. No, it's positive because the 164 is the bigger one in absolute value. Then on my calculator, I just divide. 63 divided by 1.50.
If you have a calculator in front of you, go ahead and do that.
And it will tell me how many adult tickets I sold. It ends up being 42. That's very good. 42. So I have to warn you on these. You have to pay attention to what they're asking. Were they asking for the number of adult tickets and student tickets, or just adult tickets? Just student tickets? Oh, just student tickets. Okay. So if my adult tickets were 42, I can do this. Student tickets plus 42 has to equal 101, right? So the student tickets will be whatever I get when I subtract 42 from each side.
It's 61. Right? No.
Oh, 59, right?
Dang it, that's so close.
That was close. So something you might be able to do in your head, although when I throw these prices in here, it makes it a little more difficult. So we've seen one example where we could just go directly to adding the two equations and it eliminated a variable. We've seen another example where we had to multiply through by -1. Some students might say, oh, just subtract this equation from that. It's the same thing. And then the third example is probably the most difficult of the ones that we have, is we have to multiply through by something other than -1 to get the variable eliminated. So here I have 3x plus 2y equals 1, 4x plus 3y equals -2. If I added these, I would get 7x plus 5y equals -1. Nothing is eliminated. But what is the smallest number that 3 and 4 have in common? Okay, that's their smallest factor that goes into each one. What's the smallest number that they can each divide into?
1.
No, that they can each divide into.
3.
Does 4 go into 6?
No.
No. So go up to the next one.
5.
12 is the smallest one that they'll both go into, right? So if I decide I want to eliminate, say, x, I need to multiply each of these by something to bring it up to 12. Or I could eliminate y. What's the smallest number that both 2 and 3 go into? 6. That might be easier. Okay? So it's your choice. But if I take this equation right here, I'd like you to do this with me. Multiply the top equation by 3, please. Because I want to take the 2y and make it a 6y. And then multiply the bottom equation by -2. Here's why. I want to make the 3y into a -6y. So when I add it to the positive 6y, the y's are eliminated. Okay? So my new equation here, go ahead and put an arrow. It's 9x plus 6y equals 3. And the one below it is -8x minus 6y equals 4. And the magic occurs here. So with these two new equations, when I add them together, the y's are eliminated, and I get 9x minus 8x is x equals 7. Voila, there it is. X equals 7. X equals 7. And then I just take the x equals 7 and plug it in to one of the original two equations. Let's plug it into the first one. 3 times 7 is 21. Subtract 21 from each side. Divide by 2. And we get 7 comma negative 10 as our solution.
That was a